So there are fundamentally two types of data, which is to say that there are two levels of measurement. Okay, remember that relationship between data and measurement, which I've been getting at before. Data is the result of, oh, I got it wrong. Data are the result. You see what I said? We do often fall back into using it as an uncountable noun, but it isn't, and don't let me catch you writing it that way. Data are the result of systematic measurement. Okay, and the data that we have are fundamentally dependent on the way that we did the measurement. And we talk about measurement in terms of levels of measurement. We can think about two basic levels of measurement: the categorical level of measurement and the numeric level of measurement. And each of those, the first one yields categorical data, the second one yields numeric data. However, we don't usually talk in terms of two levels of measurement. We usually talk in terms of four levels of measurement, and those four are subcategories of the two from the previous slide. Okay, so we can talk about the collecting data at the nominal level. We can talk about collecting, or which is to say, making measurements at the nominal level. We can talk about making measurements at the ordinal level, which means that we're collecting ordinal data. We can talk about taking measurements at the interval level, in which case we collect interval data, and we can talk about taking measurements at the ratio level, which gives us ratio data. And there are these four categories there, and it all depends on how the measurements were made. And nominal and ordinal data are subcategories of categorical data, and interval and ratio data are subcategories of numeric data. What do all these things mean? Well, with categorical data, observations are categorized. So the process of measurement is simply a process of saying, does this thing belong to one category or another category or possibly a third category? That's what we're doing every time. Okay. Now with categorical data, there must be a finite number of categories. For example, if we were taking measurements at the level, if the thing that we were interested in measuring was biological sex, there are two categories. There are only two. Okay, you can only categorize something as male or as female, or somebody as male or as female, if we're looking at that biological level. And when measuring will be a matter of saying, I don't know, let's look at mice. Let's say, okay, for each mouse we will see, is that one male? Yes. Is that one female? Yes. Male over here, female over there. Two more males, put them over here, one more female over there. Mice, whatever, cats, people, that's what we would be doing. Now, there can be no intermediate cases, and I hope I haven't offended anyone so far. I've been talking about biological sex, okay, which does not, strictly speaking, have intermediate cases. It doesn't. If there are intermediate cases, then we need another category. So if we are not measuring biological sex, but gender, then we can have as many categories as our theory of gender allows. But still, we only have those categories. So we could say masculine, feminine, non-binary. We could have more categories than that. We could have 4, we could have 5, we could have however many, depending on our theory of gender that we're working with. But we can only have that many. Okay, we can't, if we've got, I don't know, 7 genders or something, we can't put everybody into one or other of those genders and then decide, oh, this person here fits halfway between 2 of them. No, you can't do that. If you decide that if you get to the point where you have to do that, what you would then your next stage would actually have to be to throw away all your data, create a new set of categories, and then start again. Okay? You can't just change things on the fly and expect that it's still going to be okay, like you could with qualitative data collection. You're going to have to, if you decide, okay, oh heck, we have somebody here that didn't fit into our 7 or 3 or whatever categories, we've got to make a new category. Well, then you have to start again with that many categories. It's like I said earlier with thinking inside the box. You choose the box you're going to think inside, and you stay in that box until you're finished. If at some point you realize it's the wrong box, you climb out of the box, you make a new box, you get in that one. But you can't just improvise on the way through, okay? This is how we do quantitative research. It is very disciplined. Everything that you do at the end has to be allowed for in the way that you laid everything out right at the beginning. And if you decide halfway through that things have got to change, you've got to go right back. What's numeric data? Well, in numeric data, each observation is associated with a number. The range of numbers may be finite or infinite. The range of numbers may be discrete, that's 1, 2, 3, 4, 5, or continuous, 1.1, 1.2, 1.37, 1.469, 1.9, 2.1, whatever. You know, if it might be continuous, in which case we can have any decimal point, or it might be discrete, so we can only have 1, 2, 3, whatever. And with numeric data, we're not interested in, well, with categorical data, we want to know if something belongs to one category or another. With numeric data, we're interested in whether one number is more or less or the same as another. Now we look at the first category of categorical data. This is nominal data. With nominal data, we have categories that have no intrinsic order. For example, male and female have no intrinsic order. Neither is better, neither came first. What about ordinal data? Ordinal data are this is where we were taking measurements by assigning to categories that have an intrinsic order. For example, gold, silver, and bronze medals have an intrinsic order. Gold is better than silver, silver is better than bronze, therefore gold is better than bronze. Now this distinction is only important if we have more than two categories. If you've only got two categories, it's nominal data. Even if there is some sort of, even if you think of one of them as being better than the other, it's still just nominal data, because actually it doesn't make any difference if there's only two. The order only makes any difference if you've got at least three categories. So ordinal data has always got at least three categories. Then we come to interval data. Now, interval data is a kind of numeric data. If we have interval data, then equal differences in measurement reflect equal differences in the phenomenon being measured. Okay? Let's say we have three measurements. A is 3, B is 6, and C is 9. 6 minus 3 is 3, and 9 minus 6 is 3. So we can, therefore, the difference between A and B is the same as the difference between B and C. Okay? If equal differences in measurement do not reflect equal differences in the phenomenon, you can't do that. You can't say gold minus silver equals 1. You can't say silver minus bronze equals 1. You can't say bronze minus gold. Sorry, gold minus bronze is 2. You can't do that. It doesn't make any sense. The person who, let's say it's a race, the person who won the gold medal might have been only very slightly ahead of the one who won the silver medal, and whereas that person might have been way ahead of the one who won the bronze medal. Let's say we don't know. We've only got the order of the medals. We don't know what the differences between them are. We can't do addition and subtraction. We can't say. And therefore, we can't do many sorts of calculations as a result. So with interval data, you must be able to say that the difference between 1 and 2 is the same as the difference between 1 and 3, and 4 and 5, and 7 and 8, whatever. And then we come to ratio data. Now, ratio data are in many respects the best kind of data. If you have data that were collected at the ratio level of measurement, then you have lots of analytic tools at your disposal which either don't work with other kinds of data, or which do, strictly speaking, work in that they produce a result, but the result is not strictly valid. So if you can get ratio data, which we can't always get, then you have a lot of options available to you. You have the very powerful kinds of analysis you can do. Interval data, basically speaking, what is ratio data? Interval data with a true zero are called ratio data. That's the difference. Where this is the case, we can compare measurements not only through addition and subtraction, as on the last slide, but also through multiplication and division. Let's say we have three measurements. A is 3, B is 6, C is 9. This must sound familiar to you. Well, we're not going to do subtraction now. Let's do division. 6 divided by 3 is 2. 9 divided by 3 is 3. And 9 divided by 6 is 1.5. Therefore, C has 3 times as much of whatever it is that we're measuring as A, and 1.5 times as much of it as B. Okay, we couldn't make that statement. We couldn't make that that comparison if there wasn't a true zero there. We couldn't do division. We couldn't do this if we were not dealing with ratio data. And being able to make that comparison is a very powerful thing to do, and you'll see that later in the course. So there we are. These are the basic concepts. I hope that you've enjoyed this lecture. I do again sincerely apologize that this lecture was uploaded late. That won't happen again. Hope you managed to do the reading. I hope you're looking forward to the seminar. If you haven't had it already, if you already have had the seminar, I hope you enjoyed it. I'll look forward to seeing you all either in my seminars on Friday or next week in the next lecture. Do check out the coding bootcamp, which was uploaded. That will give you an introduction to how to use R. Now, when we get to do our analysis later in the course, you will find that very helpful. Okay, because we're going to be working with R this time. We used other software solutions in previous times when I've taught this course. This time we're using R so that students who did the 7AAVBCS1 module can go straight onto this and you employ the same skills. That coding bootcamp will act as a revision. If you didn't do 7AAVBCS1, it will act as an introduction. There's two parts to it. There's the slideshow, which explains the concepts, and then there's a little demonstration in which I actually show you how to do some stuff in R. In both cases, you can follow along with the video, pause it as many times as you need to, and try to replicate what I'm doing. We also have this year for the first time, and I didn't know about this at the time when I was planning the course, but we also have special coding workshops in the Digital Humanities Lab. Those are again based around R. They will support data analysis in lots of different ways. They will be extremely useful for you on this course, and they will help you to put into practice the kinds of processes and techniques and concepts that we're learning on this module. Okay, well, yeah, great. Thanks for bearing with me. Apologies once more. I really hope you enjoy this course, and I'll see you around. Bye.